Welcome back. I wanted to start by thanking everyone for making yesterday's discussion sessions lively and exciting, and to extend an additional thank you to our panel session moderators, Samson Hagos and Kris Karnauskas. They will now give summaries of the outcomes of those sessions. So go ahead, Samson.
So this session focused on model basis over ocean atmosphere interactions. What are the key processes that we need to understand and represent, and to that end, what targeted observations could be designed. This summary is a compilation from notes taken by Kayla, Trushka, Charlotte, and Caitlin Berber. So the questions that were guiding this discussion are listed on top here. The first one is, what process caused the leading model biases over the tropical Pacific that could be better understood with targeted observation? So the key observation from the discussion is that there are so many of them, and we sort of have to pick and choose. So the first one is related to the edge of the whirlpool, where you have sharp salinity gradients, and there is a lot of ocean mixing and related precipitation and circulation processes. The other problem relates to vertical exchange over Eastern Pacific, where you have shear-driven mixing, including the diurnal time scales. So we have very shallow thermocline. So the mixed layer is very responsive to variability in energy input. The other problem relates to the feedback to the atmosphere, specifically how the atmospheric convection responds to sharp SST gradients. There was also discussion related to upscaling, sort of rectification of processes such as diurnal cycle into the low frequency variability. Related to the freshwater supply from precipitation is barrier layer formation and feedback into SST and circulation. So these are only sort of a sample of these problems discussed. So in terms of narrowing them down, what can be observed and constrained through targeted observations, there was discussion of precipitation-induced fresh jets and how they relate to low frequency variability. The other problem was, how can one observe the vertically resolved turbulent heat fluxes over the ocean? The rectification of diurnal cycle onto interannual variability and intraseasonal variability, and there was this idea of using biogeochemical tracers as constraints on the vertical circulation and mixing over, specifically over Eastern Pacific. Then we discussed the sort of potential design of observations that could be aimed to address this problem. So one idea that was presented was having a mobile mesoscale network that could be moved, for example, east to west, or seasonally, to fill the gap over the TPOS backbone, and sort of bridge the gap also in the temporal scales. And then you have another challenge of trying to get long-term statistics that could be potentially addressed using a super sites at multiple regimes, for example, at Central Pacific and over Eastern Pacific, and also the utilization of satellite data. And then you could, once you have this infrastructure, then you can also do targeted process studies over different locations and exploiting the backbone observations. For example, the other idea that was presented was trying to increase the resolution of these backbone observations, some using additional observational sites that so that one can capture, for example, tropical instability waves. Other themes that emerged from the discussions are sort of, the first one is more of philosophical. How do we approach this problem? Do we approach it from regime sampling based perspective, or through sort of trying to get fundamental process that's applicable throughout the globe? So the idea is that once you have a basic understanding, then you can sort of narrow down into the locations that gets you the sampling that you need while designing your observations. And then the other approach is you could try to sample various regimes depending on the process of interest. For example, you can look at upwelling, freshwater pools, trade winds, regimes, and other processes. So to that end, you can focus on over, again, eastern edge of the warm pool or equatorial Eastern Pacific, or the regions of tropical instability waves. I think that's all I have. Thank you.
Okay, thank you, Samson. Maybe it would be best to move on to Kris's summary, and depending on how much time is left after that, we could take one or two questions.
Okay, so I will try to quickly summarize the rich discussion we had following presentations by Kai-Hong Wen, Jack Reeves-Iyer, Yolanda Serra, and Yosuke Fuji about Earth system predictability and predictions. I think we were supposed to skip this slide. Okay, so one of our guiding questions was, what is the current understanding of the optimum initialization for multi-scale processes? Okay, it's a multi-part question. What observations contribute to improving the initialization, and what observations might lead to improved parameterizations? So three themes that emerged during that discussion were that coupled data assimilation with ocean and atmosphere should be in balance, and that's optimal for simulation and forecast of multi-scale processes. We talked about direct covariance measurements for air-sea fluxes, ways to estimate the uncertainty of those estimates in the algorithms, and using them to validate bulk flux algorithms. We noted that, of course, this is difficult to make those direct measurements at a large scale, which sort of underlies the a paradox that we need large-scale global observations of fluxes that are free of the same algorithms that we're trying to validate. And yeah, we talked a bit about the information contained in the initial uncertainty or the ensemble spread from the observations, and their uncertainty, and that this spread should be embraced in its useful information. Another guiding question for our panel was what model improvement is necessary for improving the prediction skill of the tropical Pacific and its teleconnection. So pretty much everything in the tropical Pacific. And how can this model development use observations effectively? So mixing came up a good bit, mixing in both the ocean and atmospheric boundary layers, as they're increasingly shown to be important in terms of explaining biases in models, but also having impacts on predictions. We talked again, bringing up bulk flux formulations and needing direct covariance measurements so that we could have a way to validate those against sustained independent measurements. And we talked about, we had a whole presentation actually and some follow-up discussion about off-equatorial advection, namely temperature anomalies that can be advected in ways that are relevant to the equatorial thermocline being important, and a number of ways to potentially address that were discussed. For example, unpiloted surface vehicles are important not just for this process, but of course getting beyond where the moored instrumentation will be and into undersampled regions. It was also brought up, I think by Luann, about the possibility of using satellite derived sea level anomaly observations to look at the heat content in sort of fill in between the moorings about the VBAR T prime term. We also discussed how air-sea interaction in the ITCZ region is really important. It's also a place that's kind of a blind spot for satellite observations, but also something that hopefully TPOS can still address. So other themes that emerged, really trying to think about what are the sampled and undersampled regions within the tropical Pacific. It was brought up that adjoint models and data assimilation tools can still be used to inform process study plans, which I know is going on right now. How do we design a flexible TPOS network to accommodate future discoveries in dynamics, thermodynamics, biogeochemistry over the next decades? And a huge question that was brought up by Elizabeth Thompson in the discussion is that, ENSO is something that is spatially distributed, temporally lagged. It's very difficult to design process studies to study something like that. So we talked for a bit about the sort of trade-off and ways that moored instruments and flexible or sort of one-off field process studies can play off each other to try to study something as big as ENSO, especially the precursors. And finally, our recommended next steps or action items. Consider this very much a draft, but designing complementary or coupled boundary layer observations that can inform coupled data assimilation, improving uncertainty in observations to inform on data assimilation uncertainty, and then forecast uncertainty. More uncrewed vehicles, such as sail drones, wave gliders, as part of the overall observing system. Recommending more OSSIs, for example, to evaluate the impact of observations in the Central Pacific, which Yolanda's presentation showed is a region where the system is very sensitive, potentially. And continuing to survey the community on what are the well-sampled regions in the tropical Pacific, keeping in mind what satellites are great at doing and less great at doing. Again, more community engagement, connecting to the UN Decade of the Oceans. And also it kind of underlying all of this as we move forward into a new observing system is that we're probably going to have a huge volume of data of different type, different frequencies, different sources, different formats. And so we noted that should be addressed early and early in the process to enable monitoring and discovery and science to effectively use the system. That's what we got.
Thank you, Kris and Samson. We are a few minutes ahead of schedule. If anyone has a quick question, please enter in the chat that you would like to ask a question. And while I'm waiting to see if anyone has any feedback there, I just think it's great. Both of these summaries reflect input from both our panelists and the audience members who attended those. So this is great. And it's also nice to see that there are some common themes starting to emerge. And I think we'll hit on these a little bit more later today. So Scott Powell has one question. And I'll just read it, Scott. So for the large-scale slow processes like ENSO, what are some specific observations that satellite data do not provide that surface-based data can? So if one of you would like to answer that in the next minute or so, then we'll move on to introducing our next moderator. Thank you.
Kris, do you want to go ahead?
I mean, the first thing that came to my mind is stratification. That's kind of something that is probably tough for satellites in the near future. I know there's been work to try to use methods to infer what stratification is using satellites, but I think that's pretty early on. So Samson, yeah, go ahead. Do you have something else?
Yes, I think the impression I got from the discussions is the mixing under the mixed layer in the thermocline would be something that is of interest to people that might not be amenable to sort of high resolution turbulent mixing to see. So people talk about sort of towers, upside down towers, to try to get to those processes.
Okay, thank you. So there were a couple of other questions that were posted in the chat. I would encourage you to maybe carry on that discussion using the Slack channels, but we will record these questions for summarizing these sessions. So at this point, thank you for both your reviews, Samson and Kris, and we'll now move to today's plenary session.